Good evening for the few who are in already. Welcome. And of course, you know that we are somewhat ahead of time. But I will not hesitate to go straight ahead. And we are working from tutorial 1, which is, I have one of them over here. And the tutorial that we are working on is the factorization tutorial. Factorization tutorial. Your book might be different from mine. I have it on page 11. You might have it on a page that is close. And we'll begin our factorization. And of course, I'll be taking on the odd numbers. That's nice. I'll be taking on the odd numbers, and we have quite a few problems. And we have 33. So if I'm doing the odd numbers, you're going to think that I'm going to be doing 17 of the 33. And of course, you imagine that it will go up all the way to 8 o'clock. Let's begin. Now, of course, I'm going to begin, but I'm going to restart. I'm not going to restart the problems because we have more than enough problems. We have more problems than we can manage. So, I'll begin. I'm going to do your restart. Not restart TikTok and not restart the problems. But when it gets to about 8 o'clock, not 8, 6 o'clock, then that's the official start of the class. Students who coming in at 6 o'clock, I don't think that they have missed anything, because the number of problems that we have to solve in this tutorial, believe me, is going to take quite a bit of time. So your first problem, one of your favorites. Your first problem is, do not forget that I'm not doing every one, I'm doing the odd numbers. A squared minus AB minus AC. So many A's plus BC. And of course, as long as you see the 4 of them, you know it's 2 by 2. And it's factorization by grouping. What was that about to go for? Alright, when I remember again, I will go. Oh, yes. So that's factorization by grouping, and we are going to take 2 at a time. And let's say, what is the highest common factor that we're going to use for the first 2? I'm soliciting your responses so that we can have an interactive class. Let's go. Let's go. What's common in these 2? If the answer is not forthcoming, then you know that I'm going to go straight ahead. So, factorization by grouping, 2 at a time, of course, and we are soliciting the common factor that we're going to be using for the first 2 terms. No answers yet? Alright, so the common factor is A. We have A here and we have it there. Then we say A into A squared is A. then A will cancel here, and then we'll have B. And the common factor here, AC, BC, you can clearly see that it is C. But we need to include the sign that begins the second pair, which is a negative sign. And of course, the C will cancel here, and we'll have an A. Then negative into positive is negative. And of course, the C will cancel, and we will have B. And there you see, thank you very much. I wonder if we're having a serious delay. Hopefully we are not having any. Hopefully if there's a delay, it's not very long. All right, so let's continue. Now, all right, since you're onto it, what's the highest common factor here now? We are here. What's the common factor that we're going to choose here? Yeah, well, in the first one, what's the common factor that we're going to use here? If you see a common factor there. For those who are familiar with factorization by grouping, or you should be, because not only we did that in class, not AB, A minus B. Okay, that's fine. I understand the challenge with typing in TikTok. And of course, when you're doing algebra, you have to use the same case in the problem. So I understand that when you move on, the case may be capitalized. You understand? Yes, I understand that. But just to confirm. So the common factor is A minus B, and do not forget that, and then the other one is A minus C. Do not forget that algebra is case sensitive. A minus B. Yes, do not forget that algebra is case sensitive. What do we have? Your favorite trinomial. No, yes, number 3. No. We're going to go all the way down to number 3. X squared minus y squared minus 4x minus 4y. That's nice. If that's not your typical factorization by grouping, but I am sure that there's something right there that you'll be able to That's very nice, man. Do graphs. Do linear equations. Linear equations will be done tomorrow in instructional class. You're not, students who are doing examination in May, June, you're not going to see graph until about February. Linear equations is tomorrow. Okay, so what about factorizing this? Is there anything that you see that you can factorize? For y2 minus 4y. Do you see anything here that you can factorize? Somebody's saying no, sir. Oh yeah, See, no, well, that's it. Because you're not on a, it's not so much TikTok, but you're not on a mathematics typing thing. So you're just on a messaging thing. So you should not imagine that TikTok will allow you to type like you're typing for a mathematics program. Not going to work. Okay, so yes, what do you see? If you see something that you can factorize, what is it that you see that you can factorize? Let me know what it is. X and Y can be factorized. X and Y can be factorized. What do you mean by X and Y can factorize? Some say I see something that can be factorized. No one can give an answer yet. What do you see that can be factorized? Y and X and Y cannot. Both. Both. I mean nothing. Oh, that's very nice, man. That's very nice. I uploaded 21 audio visuals on TikTok about factorizing a difference of two squares. And now, students are logging on to tell me that you don't see anything that can be factorized. That's very nice, man. You mean nothing? Oh, just do it. But it was already done for you in TikTok. This problem was solved for you already, you know. And loaded onto TikTok. So every problem that I'm going to be solving now, especially the basic factorization, the factorization by grouping, and the difference of two squares. All of those problems that I'm solving now were already loaded up on TikTok. And what's excellent about that is that I don't have to tell any lies, because you can just go through TikTok, scroll through and find the right one and just click on it, and then you'll see the entire problem solution coming up. But it is disastrous if there is no one who is joining now who cannot identify a difference of two squares. So no one here sees that this is a difference of two squares. And then no one here cannot factorize the difference of two squares. So what I need to do, just go and just do it. Will that help? Alright, if doing it will help, then let me just do it. This is the difference of two squares. X plus y, x minus y. And of course for this, you have a common factor of 4 right there. And I'm not so sure that this is minus, maybe this is minus, this will be plus. So let me take a second look at it. Yes, it is plus. So let us take the common factor of, put the negative sign there, of negative 4. Then we'll get x. Negative into positive is negative. and then we have y. So what's common there? You can see the x minus y is common. X minus y is common here. X minus y, that's your common factor. And then if you take out the common factor of x minus y, what will be left is x plus y minus 4. So take these out, you'll see that what's left is x plus y minus 4. So that's your number 3. I'm going to go to number 5. Number 5 is, what would I say about it now? Number 5 is somewhat cumbersome. 1 minus all of a plus b all squared. You could just repeat what you saw in the other visuals on TikTok. Just repeat what you saw on the other visuals on TikTok. That's all you need to do. Because this one surely is there also. And it is there as a difference of 2 squares. Although, of course, one is a square, and there's no doubt that this is a square because it says exactly a plus b all squared. So what do you square to give 1? What do you square to give 1 is 1. And what do you square to give a plus b all squared? A plus b. So it's going to be 1 plus a plus b. And then the next one is going to be 1 minus a plus b. So we'll have what? If you work this out, you'll have 1 plus a plus b right there. Then if you work this out, you'll get 1 minus a, and this negative sign is pertaining to both a and b. So you have 1 minus a, and the negative sign is going to be distributed to the b also. So that is going to be minus b. That's it. So that's all. Number 5, this is the first part of number 5. I think that number 5 has another part that is a little bit more cumbersome than that one. But we can work it out. They wouldn't give us something that we shouldn't be able to work out. This is Roman 1. And this is Roman 2. Two x squared plus xy minus y squared plus 2x minus y. Now students, when you are about to solve a problem that is like that, there are some things that you'd want to bear in mind. Maybe you do not want to take this out of the bracket and combine it with that. Right? I think that they're giving us some assistance by putting these in parentheses as you have them right there. Right, so they are in parentheses, keep them there. And then what do you imagine? If this entire thing can factorize, then I'm making a prediction that when I factorize this, one of the factors will be 2x minus y. If not 2x minus y, then negative 2x plus y. But it has some semblance, or it will have some resemblance to this. That is what I would predict. But it's not a bad prediction. Because if the entire thing can be factorized, then this should be involved in one way or the other. What about this? Let's go. It's a trinomial. So let us factorize that one. Where am I going to find a problem now to give you, and you'll try and answer? All right, I'm going to attempt and see. As long as you don't look over, then we will have more than enough of them. Somebody is saying good night, some say good evening. Good evening. Good night. So let's go. Let us factorize this in true trinomial form. What two numbers multiply to give this times the coefficient here? The coefficient here is 2. The coefficient here is -1. What two numbers multiply to give -2? And when we add them, we multiply them to give -2. And when we add them, the result is the coefficient here. So they are multiplied to give -2, and when we add them, we get a 1, because the coefficient here is 1. Multiply them to give the -2, and when we add them, we get a +1. What are those two numbers? Those will be the two coefficients of the two middle coefficients. The two coefficients of the two middle terms. All right. So let's go. The product is -2 and the sum is a +1. So the two numbers are +2 and -1. So that will be the coefficient. Those will be the coefficients here. A plus 2xy, a minus xy, a minus y squared. Then plus 2x minus y. That's nice. That's big and broad. What next? So, in true factorization by grouping form, let's take the common factor of these two. The common factor of these two, what's that? Two x is correct. So we take 2x as the common factor, and then 2 will cancel here, and x into x squared is x. And the 2x will cancel the 2x here, and y will remain. Negative sign. What's common in xy and y squared? What's common in xy and y squared? Is it? Yes, xy and y squared. Yes, thank you very much. That was fast. So we say now, the y will cancel with this, and we'll have the x. Negative into negative is positive, and y into y squared is y. And we are kind of through there. Then we have plus 2x minus y. And of course, inside of our trinomial environment, because we are keeping those terms in the trinomial together so that they are not contaminated with the ones that we have over here. They are not contaminated by those. So what's common in these? X plus y. And then, of course, 2x minus y. 2x minus y. That's nice. Then plus, see, you have your 2x minus y right here. And you have the 2x minus y right there. if it does not factorize immediately in the way that you imagine or you do not see that, then it will be best to call this to be what? 1 times 2x minus y. Like that. And of course, across the board, you can see the common factor here is, what's the common factor? I'm always giving a hint as to what the common factor is. What is the common factor right there? What's the common factor of this step? I have not seen the correct answer yet. What is the common factor of this step? Look at it all the way out. Look, what's the common factor of that step? X, 2x. Look at this. Look all the way out here. Look straight across from here. Look. What's the common factor? I'm going to give just a few seconds more. Alright, somebody is still insisting that it's x. After 10 people give the answer as x already. Students, you don't see a 2x minus, you don't see a 2x minus 1 here? And a 2x minus, oh, good. Alright, so this should have been what? Man. This should have been 2x minus y. So the common factor would have been what? 2x minus y. And then what's in the big bracket? Everything is left. So 2x minus y is the common factor, and we'll have x plus y plus 1 in the next one. X plus y plus 1 will go right here. So nothing for number 6. Let's go to number 7 because we are doing the odd numbers. 1 minus 9x squared. So for number 7, Roman 1, is it Roman 1? Yes, 1 minus 9x. 1 minus 9x squared. One minus 9x squared. 1 minus 9x squared. Let me see if that's correct. Yes, 1 minus 9x squared. That's your... Can anybody, someone say, give us one to factorize. I'm going to give you this one. What are the factors of that? What are the factors there? 1 minus 9x squared, what are the factors? No answer? So one of the factors is 1 and the other one is 3. That's what you said. Like that? So if I'm factorizing this, I would write this. Well, I think that you'd have done a little bit better with that. That would be fine. So it would be 1 plus 3x, 1 minus 3x. That looks better. Roman 2, I think no, Roman 2 is a trinomial. 3x squared minus 7x minus 6. 3x squared minus 7x minus 6. What do? We multiply these two and say what two numbers multiply to give a negative 18, and when we add them we get a negative 7. They multiply to give a negative 18, when we add them we get a negative 7. When we multiply them, we get a negative 18. When we add them, we get a negative 7. What are they? I hope that is the same in your tutorial. Somebody's pointing and says 11. I think it's page 11. It's page 11 in my book. It's not, but if we are doing factorization in your tutorial 1. Let's continue. It's page 11 in my book. So your page would probably be either page, I see one of them saying is negative 9 and a positive 2. The larger one must be negative, and one says 9 and negative 2. It surely is negative 9x plus 2x. Why? Because the answer will take the same sign as the larger. And then we're going to factorize by grouping. 3x is the common factor, x minus 3. And in this case, 2 is the common factor, x minus 3. So when we are through, we should get what? X minus 3 with 3x plus 2. X plus 2. Number 9. For x squared minus 16. Alright, first of all, I'm looking, where is it in comparison to the left? Well, it's above it, so we can factorize like that. Tutorial 1. And I think it's going to be for you, if it is not page. No, I'm going over now onto page 12. So I'm going over onto page 12. Can anybody factorize this? Two times 2 plus 4. Yeah, it might look a little bit different, but the problems are the same. Yeah, it might be a little bit different because we edited the book from time to time. Somebody's saying it's squared. What do you say about that one? She's saying 2x squared plus 4, 2 and negative 8. Students, this problem is on TikTok already, you know. So this problem was uploaded. The solution of it is uploaded. Gives you all of the ins and outs. So I would just expect that when you get here, all you do is just repeat something that you have seen there. Two and 8. Oh. Two x squared minus 4. Alright. Well, this is in the form of a difference of two squares. No doubt. So because it's in the form of a difference of two squares, the students might want to factorize it like this. What do I square to give 4x squared? What do I square to give 4x squared? 2x. What do I square to give 16? 4. If you do that, because it's in the form of a difference of two squares, you factorize it like the difference of two squares. That's correct. But for the intents and purposes of the CXC examiners, although that is a correct factorization, it is not the correct factorization, because the factorization that the examiners will ask for, I see a 4 there, the factorization that the CXC examiners will ask for is a complete factorization. So the examiners want a complete factorization. What do I mean when I say a complete factorization? First of all, this expression has a common factor of 4. So that's the first thing. It has a common factor of 4, as someone was pointing out. Right. So there's a common factor of 4. So if there's a common factor, you should take the common factor out first. So you take the common factor of 4 out, then you have x squared, and then 4 into 16 is 4. Then, of course, you still have a difference of 2 squares. You still have a difference of 2 squares right here. So in that case, what do we square to give x? What do we square to give a negative 4? Or to give, what do we square to give a 4? Not a negative 4, a 4. And then all you need to do is put your signs in and you're through. you should not be now struggling to factorize the difference of two squares, because we have 21 problems on difference of two squares loaded onto TikTok. Nice. Continue with number 9. No, there is no continuation. So we'll move to your favorite, number 11. I think that you should be able to see that. Maybe I should adjust it back a little bit. That will cause it to be more visible. Right, so can anybody factorize this? What do we say? Of course, there's another difference of two squares that you have right there. So, the square root of 9a squared will go there. The square root of b squared will go there. Put the negative sign first. It doesn't matter which one I put first. The product will be the same. I think that number 11 has a second part. It does. Yeah, your favorite. Factorization by grouping. Roman 2. No, that's not it. We're still not number 11. Let's go. 3x minus 8y minus 4xy plus 6. Of course, as soon as you look at that, does anyone notice something? 3a minus 1 and 3a plus 1. It's b. It's not 1 squared, it's b squared. What about that one? What do you say about that one? Apart from nothing. Anybody notice anything special about that one? Say yes. And tell me what it is that is special about it. Alright, so a few seconds. Right. It's not that there isn't any like term, but we don't have like terms that are beside each other. So the like terms are not beside each other. Maybe if you put it or switch it around a little bit, then that will say something. It's easy. Usually, when you're switching something around like this, you should only move one term. Right. So, in that case, you should only just change one term. Just move one term. So we'll move this 6 and put it here. So we put this 6 at the front and we have 6 plus 3x minus 8y minus 4xy. And then, of course, it will work. What's common in these two? 3. Then we have 3 into 6 is 2. The x's will cancel there. Sorry, the 3's will cancel there. Of course, your common factor here will be negative 2y. And what do you say? 2 into 8 is 2, and the y's will go away. That's not it. 2 into 8 is 4. The common factor is actually larger, a 4y. So the common factor, if we use 2y, we will not be using the highest common factor. Right, so if we use 2y, we will not be using the highest common factor. So we use 4y. Of course, in this case, the y's will cancel, and 4 into 8 is 2. Negative into negative is positive. The 4's will cancel, and so the 4 will cancel, the y will cancel, and all that is left is x. Surely, you should be able to see the common factor right here. 2 plus x, and then when 2 plus x is cancelled in each case, we'll have 3 minus 4y left. Nice. Number 13. Number 13, I think, is number 13, I'm not going to say anything about it, I'm just going to put it on the board. What is that equal to? What's the highest common factor right there? Look at that one and let me know the highest common factor, if there's any. What's the highest common factor? 8 AP. That doesn't look complete. The 4 is good. The 4 is good. We have p cubed and p squared. Is p the highest common factor for that? Thank you, Mr. Bugatti. At least I have seen it this time. Let's go. We say 4p. We have p cubed here and p squared there. What should we use for p? 4p squared is correct. What about the q? What about the q? Q and q cubed. No one saw that there's a q that is common? No one saw that q is present in both terms? What about the q? We have q and q cubed. Yes, just a single occurrence of q. Then what do we say? 4 into 12 is 3. P squared into p cubed is p. The q's will cancel as you can see. Then we go to this one. 4 into 8 is 2. P squared will cancel the p squared. That's gone completely. And q into q cubed is q squared. And that's your final answer. Nice. At this point in time, I would like to say again, a big welcome to the students who are here. Good evening to everyone. What else is there to say? Thank you for joining. Thank you for sharing. Thank you for participating. Thank you for the rose. And thank you for inviting others. Students, when I come to the tutorial, you see, if you take advantage of everything that I do, you'll sail through everything. Because I'm loading up the videos on TikTok, and some of the students are, it appears to me that the students are seeing these problems for the first time. And look how many audiovisual on TikTok. Look how many audiovisuals on TikTok. Look how many audiovisuals I've loaded onto TikTok with everything that's pertaining to what I'm doing. Some say that they've gone over to Google. That's nice. Go on over there. Just go over there. That's nice, man. Very nice. So, let us move merrily to number 15. Number 15 is nice. So the first one is to factorize for number 15, x squared minus xy. X squared minus xy. Of course, you can just see the simple common factor there of x. X into x squared is x. And the x will cancel here, leave the y, so it's minus y. No problem. This one should be a difference of 2 squares. I hope it is. E squared minus 1. E squared minus 1. That's a difference of two squares. What are the factors? That one is too easy. Let me just give you some time. Let me give you some time to take a go at that one. E squared minus 1. What are the factors? Number 15, come on, look at number 15. Well, the one that I'm doing. Student, all right, say this is a different number. Let's say it's a different number in your book. If it's a different number in your book, just look for the one that has this. It has to be the same one. So that's what this will be what? E plus 1, E minus 1. So let me see. We have 5p squared is correct minus 9p cubed minus 2q squared. There you go. That's your trinomial. The two numbers multiply to give a negative 10. They multiply to give a negative 10. And when you add them, you get a negative 9. What are they? Let me tell you how to do it. Open your tutorial book. First page. I'm going to go for the book that quite likely you have. Alright, so I'm here now with the book. 10 and negative 1 seems correct to me, yes. I'm going to... I look here for factorization. Okay, alright, so when I open the book, that's quite likely that you have this one. Where you see the table of content page. Do you have the table of content page like that? Yes, you have the table of content page. You see factorization, and when you look, you see it's on page 8. So you go to page 8. When I go to page 8, I see the factorization beginning there and continuing over onto pages 9 and 10. So that seems to be number 15. And if number 15 that I have in this book is the same. Because if it weren't the same, it would have just been maybe a little number off. Alright, so let's go. Alright. Oh yes, so I think that I see the 10 and negative 1. No. I need a better answer than 10 and negative 1. Do I have a better answer than 10 and negative 1? Negative 10 and a positive 1. Minus 10pq plus pq minus 2p. So let's go. Common factor here. 5p. Then the 5 will cancel and p into p squared is p. And then 5 into 10 is 2. The p's will cancel and we'll have the q. What's common there? Obviously the q. The p goes back because q will cancel the and the p, and then the q. How do we have a negative 2q? There's nothing to divide the q, the 2, sorry, nothing to cancel the 2, it goes back. And q into q squared is q. Finally, common factor is p minus 2q, as you can see. And then what's left? 5p plus q. Nice. That's what? The end end of number 15? G. Any more? Sure. 17. I'm going to put number 17 right here. 8h, I'm going to put it closer. 8h squared minus 4h. That is easy to put beside it. Because we see a common factor of what? What's the common factor here? I'm giving you the chance to take a go at that one. Let's go. What's the common factor in that? 8h squared and 4h. Just that? The 4 alone? You don't see anything else that's common? 4h. Then 4 into 8 is 2. And then h into h squared is h. And of course, you can take the entire 4h and divide it into 4h. Anything divided by itself is 1. I'm going to put that as Roman 1 for number 17. 4a squared minus 1 is your favorite. Roman 2, 4a squared minus 1. That's your difference of 2 squared. 4a squared minus 1. 4a squared minus 1. That, of course, is a difference of 2 squares. What do you say about that one? Alright, since no response, that's a difference of 2 squared. What do we square to give 4a squared? 2a. What do we square to give 1? 1. So, that's your finished product for your difference of 2 squared. Students, even this problem is on TikTok. All of them. Every single difference of 2 squared that we are looking at in these tutorials, they are already loaded on TikTok. Move merrily to number 19, and number 19 contains one of my favorites. But I'm going to do Roman 1 right here. Roman 1. And what does Roman 1 say for number 19? 15x squared y minus 20xy squared. That's nice. 15x squared y minus 20xy squared. You can see the symmetry in that. There's a part of it that's symmetrical, so seeing that symmetry, you should not be factorizing this erroneously, and it shouldn't take a year also, you should factorize that very quickly. What's common in 15x squared y minus 20xy squared? What's common? Alright, so let's go. 5x alone. So common is 5xy. And of course, you'll see that in the first case, x into x squared is x and the y will cancel. In the second case, the x's will cancel and y into y squared is y. So you should see that symmetry and know that your answer should be what? 3x minus 4y without hesitation. And for number 19, we have Roman 2. What does it say? 3 minus 12b squared. And I've given one like this, 3 minus 12b squared. And I gave you one like that in class exercise. Sure. I gave you one like that in class exercise. And no doubt that one is also loaded onto my page. Alright, so for that one, 1 minus 4b, that's nice. That's nice. But it could have been a little bit nicer. The common factor here is 3. When you take the common factor of 3, we're going to have 1 minus, and of course 3 into 12 is 4. So 4b squared. So 1 minus 4b squared is the difference of 2 squares. 1 minus 4b squared is the difference of, this part is the difference of 2 squares. 1 minus 4b squared. That's the difference of 2 squares right there. So your factors will be 1 minus 2b, 1 plus 2b. $21. That's nice, man. 21 has 3 portions. Also, it's number 23. Also, number 25. No relaxation until you go to number 27. But let's go. Number 21. What does the first part of number 21 say? 2y squared minus 3y. 2y squared minus 3y. Come on, students, don't spend the entire night on that one. Two y squared minus 3y. Let me just do it right away. Take out the common factor of y. Nothing to cancel it, 2, it goes back. Y into y squared is y. Minus sign. Nothing to cancel it, 3, it goes back. And then the y will cancel it. So that's the final answer. Roman 2. (81 minus n squared). 81 minus n squared is the difference of 2 squares. Let's see what you make of that. Difference of two squares? Yes. What do you make of that? Okay. I cannot believe it. So that's 9 plus m, 9 minus m. Two x squared minus x minus 15. 2x squared minus x minus 15. 2x squared minus 15. The two numbers multiply to give a negative 30. They multiply to give a negative 30. And when you add them, you get a negative 1. What are those two numbers? Multiply to give a negative 30. When you add them, you get a negative 1. Okay, since the answer for this one is not forthcoming, okay. So let's go. I have a product of negative 30 and a sum of negative 1 minus 6x plus 5x. Then what's common in these two? 2x. Then we have x minus 3. Then what's common in these two? 5. Then we have x minus 3. So finally, what? X minus 3, 2x plus 5. Number 21, I think that's Roman 3. Number 23, I think that's Roman 3 also. Alright, I guess this one, Roman 1 for number 23 is y squared minus 3y. And of course, we're going to put it right beside it because it's going to be short. It's not going to be so wide. Let's go. Y is the common factor. Y into y squared is y. And y will cancel with y right here, and we have a negative 3 there, and that's finished. And for number 23, we'll continue with Roman 2. And what does Roman 2 say? 9x squared minus 1. 9x squared minus 1. I think I'm going to put it a little bit out somewhere. 9x squared minus 1. Good evening. Good evening, Miss Nish. Difference of two squares again, students. All Alright, when I put the difference of two squares on the board, you should not be hesitating. For 1, because it's simple. 2, we did the entire thing in class. 3, the same video on this problem is on TikTok. And Roman 3, now for number 23. 8a squared minus 2a minus 1. 8a squared minus 2a minus 1. We're going. So let's see what we make of that one. A product of negative 8 and a sum of negative 2. A product of negative 8, I'm not going to give you a long time to do this. The product of negative 8 and the product of negative 8 and the sum of negative 2. Let's go. I see the negative 4 with the positive 2. And there's a problem like this in your factorization by grouping. So we take the common factor of 4a, then we'll have a 2a there. And of course 4a into 4a, anything divided by itself is 1. There does not seem to be a clear factor right there, so we have a plus 1. And then what do we say? 2a minus 1. I'm going to leave the next one so you can. I'm almost sure that we have big bright glare inside there. So what do we have now? 2a minus 1 is common, then 4a plus 1. I'm not sure that I even have any number in, okay, it's Roman 3. $25. I think 25 has 3 parts also. 3xy minus x. Three xy minus x. Of course, you can see the common factor. For the common factor factorization, let us not stay all evening and attempt to do it. The common factor is x. You take out the x here, you have 3y. Then you take the x here and negative 1. And you are done. Of course, that is 25 Roman 1. 25 Roman 2, quite likely it's a difference of 2 squares. No. It's a combo problem. X minus, so those students who like to eat combo, let's see what you make with this one. Yeah, for those students who like to eat combo, let's see what you make with of that one. Alright, so of course, look at my first step. X minus y squared, all squared. Negative 1. Negative into negative is positive, and of course 1 into x is x. Negative into positive is negative. And 1 into y is y. So you can see here, it looks like this. I'm going to put it beside it. It looks like this. Z squared minus 1. That's what it looks like. Because x minus y all squared, let us call that z squared. And it's going to be negative 1 times z. So what do? You take out the factor of, the common factor of z, and you'll have z into z squared is z. And then z will cancel with the z and leave a negative 1 there. So it will look like that. So take out the common factor x minus y. X minus y into x minus y all squared is x minus y. And then the x minus y will cancel the x minus y here and give negative 1. We shouldn't really have to put it in square brackets. And that's all there is to it. Roman 2 for number 25. Just open your eyes. And then Roman 3. I'm not surprised that they would give us this one for Roman 3. 4a squared minus 9. 4a squared minus 9. What is that equal to? Just a few seconds for that. Of course, it's a difference of 2 squares. What do you square to give 4a squared? 2a. What do you square to give 9? 3. So 2a goes there and 3 goes there. 2a minus 3, 2a plus 3. Your difference of 2 squares, and number 25 is finished. Number 27. For x squared plus y. No. Number 27, 4y squared plus y. 4y squared plus y. That's a common factor factorization. No. How long do we have left for this snack? We have 40 minutes left. Alright. If you take a break, we'll have to pause it and TikTok. Because they love to say, right, if you take a break, I'm going to pause it. Alright, you can take a snack. What I'll do, I'll demonstrate the mathematics resources to some students. Y is a common factor, and then 4y plus 1. That's Roman 1. Let's see if Roman 2 will hold up there. For number 27. No, it's a trinomial. I have to write it below the light. Six x squared plus 13x minus 5. I like this one. Well, I'm going to leave that on the board for a few seconds. So, there are a few things that I would discuss with the students. Alright, let me know, students, you have to send me a message request, that's what they call it on TikTok, for all of the students who will be doing the examination. And say you're not in 11th grade and you want me to assist with the signing up for those examinations coming in May. You let me know, because the time is coming up very quickly when all students should be signed up for the examination. So I'm just mentioning that then. Concerning the mathematics resources, if you're interested in the mathematics resources, then you speak to me or you send me a message concerning it. I'm not going to spend and waste any more time demonstrating and tell you how useful it is. If you want to purchase them, you purchase them. If you don't want to purchase them, you don't purchase them. There are consequences for each one of them. You'll do the one that you want. Right? So that's that for the mathematics resources. I'm not mentioning it, showing you and telling you this, that. No. I'm not even going to bring you to the water much more, trying to force you to drink it. So if you want to buy it, you buy it. If you don't want to buy it, don't buy it. When the examination time comes, don't be bothering me and say, oh, Mr. James, we need this book, we need this book. No, bother with it. That time I'm going to be too busy, for sure. Alright? Okay. Like today, I went out to work on some projects that I'm working on, and I am 100% tired and 99% asleep right at this moment. So there's no need beating the donkey. And what the next one I say? Alright, I'm not going to use that one. You better know. But I think that I can manage maybe the entire, because I decided to do the entire odd numbers, and I think that I will get through with them. For sure. Yes. I will. You know? I will hold it out to the end. So, we're going to factorize that trinomial. I think it's Roman 2 for number 27. The two numbers multiply to give a negative 30, and when we add them, we get a positive 13. Yeah, when we multiply them, we get a negative 30. When we add them, we get a positive 13. Let me hear what you make of that one. I'd like to see what you make of that one. Alright, no answer? 6x squared plus 15x minus 2x minus 5. Then 3x is common. 2x squared plus 5 minus 1, 2x, sorry, no square there, 2x plus 1. So we'll have what? 2x plus 5, 3x minus 1. And of course, we have quite a few trinomials. The videos, the other videos for the trinomial, I'm going to put those on. So, at the appropriate time, you'll have a lot of fun. So the trinomials, I've not loaded the trinomials. I've not uploaded those as yet. So I will do that in short order. Because I think that only trinomials are left now. Apart from maybe another 6 or so. Then you'll have all trinomials. But let's see for number 27 if that is the last one. Yes. Number 29. 3 parts of number 29. 3 parts. No. For those students who will sign up and do the SBA, send me a message. Number 29 now. You are enjoying yourself with this one. Roman 1. 4x squared minus y squared, which you identify as a difference of 2 squares. Let's go. Difference of 2 squared. What do we square to give 4x squared? 2x. What do we square to give y squared? Y. 2x, y. I'm going to switch them around this time, a plus and a minus. Roman 2 first. It's a long time I've not seen this. 6n plus 4n minus 9kn minus 6kn. Your factorization by grouping. I'm going to zip through number 29. What's common between in this? 6m with 4n, just 2 alone. And we'll have 3m plus 2n. A minus sign for that. 3k is common. Then we'll have what? 3m. Negative into negative is positive. The 6 is 2. The k will cancel and you'll have the n. So we'll have 3m plus 2n is a common factor. Then we have what? 2 minus 3k. Finally, Roman 3 for number 29. 2a squared plus a minus 6. 2a squared plus a minus 6. The two numbers will multiply to give us a negative 12. They have a product of a negative 12 and a sum of positive 1. A product of negative 12 sum of positive 1. No response? Alright, let me go forward. A plus 4a and a negative 3a. So what do we have now? 2a is common, and a plus 2 and a plus 2. Minus 3 is common. Negative into negative is positive, and 3 into 6 is 2. So we'll have a plus 2 with 2a minus 3. That's nice. So number 29. Number 31 has 2 parts. Roman 1. X squared minus 1 over x minus 1. I remember uploading that one, you know. Yeah, there are quite a few of them that I remember. We have 77 factorization audiovisuals. Right, so that one says simplify. You cannot simplify a fraction unless you have factors that are common to both numerator and denominator. So that is why you can simplify this. 6 over 9. But you cannot factorize, you cannot simplify 7 over 9. Because 6 is 3 times 2 and 9 is 3 times 3. So they have the factors. So the common factors you have 2 over 3. You cannot do that with 7 over 9. Surely you can do that with this. And you can just cancel right away. But because the fraction is algebraic, I think that it's more appropriate for you to factorize both numerator and denominator if possible. Let's go. Of course, the numerator is a difference of 2 squares. X plus 1, x minus 1. And of course, there is no further factorization of the denominator. So this will cancel with this. And the result is going to be like x plus 1 over 1. So x plus 1 divided by 1 is the same as x plus 1. Roman 2. For a b squared, I think that's what I've seen, plus 2a squared b, plus 2a squared b over ab. In the numerator, you have what? 2ab as a common factor. 2 into 4 is 2. The a's will cancel and you have b. 2 into 2 is, that will cancel. The 2's will cancel and a into a squared is a. And the b will cancel also. b into b, that will cancel. And we have what? Over 2 AB. What is the result? You can see the AB will cancel there. There is no 2 in the denominator. And what's left? 2 times 2A plus B. If you want to simplify like that. So you cannot simplify unless you have common, or you have factors that are common to both numerator and denominator. (31), 33 now. All 3 parts. Let's go, because that's the last one for me. 5a squared b plus ab squared. 5a squared b plus ab squared. Factorize that, what do we get? The common factor is AB. Nothing to cancel the 5, it goes back. A into A squared is A, and the B will cancel. Right, so A will cancel there, A, and B into B squared is B. And that's all. Alright, that will be fine. No, it's inside of the spot. So let us do it under. Difference of 2 squares. What do you square to give 9k squared? 3k. What do you square to give 1? 1. Roman 3, which is our last problem. I love it. Two numbers multiply to give 4 and add to give a negative 5. Two numbers multiply is A. You have AB here, then 5A plus B. And that's what I have. Let me have this one then. The product is 4 and the sum is negative 5. Exactly. When the sum is greater than the product, one of the numbers is 1. So 2y is common there. Two into two, they will cancel, and y into y squared is y. 2 into 4 is 2, and the y's will cancel. There is no obvious common factor, so let us say 1. But we have to have a negative sign there. Negative into positive is negative, and anything into 1 into 2 is 2. So we have what? Y minus 2 is common, and 2y minus 1 is uncommon. And that's all that I'm doing. Students, you're not looking at the audio visuals on TikTok. You're not practicing. You're just waiting for me to sign on. And when I sign on, you come on. And I have so many things for you to learn from. You have the instructional manual to go through. You have your tutorial book. I'm uploading audio visuals on TikTok, and I'm teaching the class. Come on, students, you have to be sharper than that. All of these, you should sail through them because all of the audio visuals are loaded up. So, of course, you know that I'm going to make one last appeal. You know, speaking to the students who will be signing up for the examination. Of course, you know, 11th grade students are not included because they are doing it in their own school. And then you have some of the students who are just attending the class and they are not doing the exam. But for those students who are not in 11th grade, you are doing the examination, you want to sign up with us, let me know. And as you can tell, I'm almost tired. I'm not going to go for the mathematics resource books anymore. All right, so thank you all for being on. Thank you for sharing the live. Thank you for participating. And the newcomers, thank you for following Richard James Mathematics Resources. And the lovely Rose, thank you, sir. For number 31. You see, if you're wrong, make sure that you're right, you know. All right, so number 31, Roman 2. Let's take a look at it. Two B plus A. Yes, it's 2B plus A. Yes, it's 2B plus A. We should see right. We should see from right here. Thank you very much. There it is. Excellent. Students, I'm overworked. So, when you see the hands go up, then you know that the class has ended. So, thank you again for sharing the live. Thank you for the gifts. Thank you for talking to other people about it. Thank you for commenting, keeping the class alive. Thank you for joining. Thank you for following Richard James Mathematics Resources. So thank you to everyone, the newcomers and the ones who have been here from the very beginning. And of course, have a very restful and peaceful night. And see you again tomorrow. So it's goodbye until tomorrow. Of course, I'm only doing the odd numbers, and I'm through with them. Okay, tomorrow. Okay.